Welcome to part 2 of our notes on measurement. Remember the first set of notes we talked about mass, we talked about weight, we talked about length and how we used meter to measure length and we used a gram to measure mass. So right now we're going to start out with volume. So the volume of a solid. If you're trying to find the volume of a solid, you cannot pour it into a graduated cylinder. Well, unless it's small enough. But let's take my keys for example. My keys are really an odd shape. And you can't just dump them into a graduated cylinder, which is one of the tools that we use to measure volume with. There's actually a method for finding the volume of irregular shaped objects, such as my keys. And we're going to use a graduated cylinder for that. And it's actually called the displacement method, or the water displacement method. And we use this method to calculate the volume. Now, if you have a object such as a block or a brick, or something with 4 smooth sides, or actually 6 smooth sides, but you can easily measure it with a ruler. If that's the case, you can actually use math to find the volume of an object. So to find the volume of a regular shaped object. Okay, and it does need to be a solid, which makes sense because if it's a liquid, it's not going to be a regular shaped object. All you have to do is take the length times the width times the height. So for example, this cube. If this cube was 3 centimeters by 2 centimeters by 2 centimeters, in other words, if you took the length times the width times the height, you would actually get the volume of the object. So 3 times 2 is 6, and then 6 times 2 is 12. Now notice the label down here in the bottom, right here, 12 centimeters cubed, because you're multiplying 3 things together, it's cubed. If we remember when we measured and found a surface area of an object, because you multiplied 2 things together, it was a square, so they squared it. But here we're multiplying 3 things together, so that's why it's cubed. Now, what happens if we're measuring the volume of a liquid? Well, the metric base unit of measurement for volume is the liter. And 1 liter equals 1 L. It can be a small case L, and you see that here, or it can be a large L. I'll see it both ways sometimes. Now, volume is the amount of space an object takes up. And you will use different units and tools to measure volumes of a liquid or a solid, if you're going to be using the water displacement method that we talked about a little bit earlier. So if we use a liquid, we're going to have to always use that graduated cylinder. But we could use a graduated cylinder for a solid, but you're going to notice something. We're actually going to use a graduated cylinder to measure the volume of a solid here in class, but the label will be different. So you can use a graduated cylinder to measure the volume of a liquid. And here you see a graduated cylinder over here. And a graduated cylinder measures in milliliters, or usually it's milliliters. At least the ones in here will be in milliliters. And to read a graduated cylinder, you need to move to eye level. So you can't be looking from up above. You're going to have to get even with where the liquid is in a graduated cylinder. And read the bottom of the meniscus. Now the meniscus is this curved thing right here. You can see how the water curves. You can see it's blown up a little bit right here. You have to read from the bottom of the meniscus. And I'll show you why right here. So if we were to take a look at this and I ask you how much water is in this graduated cylinder, if we measure from the bottom of the meniscus, in other words the bottom of this curve, you can see that, well, if this is 50, I can see that's 60. So 50, 51, 52, it'd be 53. If you read it from the top, you'd be off by a milliliter. And the reason for that, here, let's go back to this slide. You can see where the bottom of the curve is and you can see where the top of the curve is. Notice there's a bunch of air space in between there. So by measuring from the bottom of the meniscus, your numbers are just much more accurate than if you read from the top of the graduated cylinder. And so what we do with the water displacement method is we will start out by reading what the measurement is, and in class I'll have you put it on an even number, for example 60 milliliters, but here it's 7. So if this was a rock and I wanted you to measure the volume of it, I'd ask you to gently place it in the graduated cylinder. You don't want to just drop it in so a bunch of this water clumps out of the top. You want to keep all that water in there. So once you drop the rock in there, you read it again. So now it says 9. So if it was originally 7 and now it's 9, just take 9 minus 7, you get 2. So it weighs 2 units. The volume of it is 2 milliliters. So you put the water in the graduated cylinder, record the measurement. Tilt the graduated cylinder to the side. Gently lower the object into the graduated cylinder. Make sure that the whole object is under the water. Sometimes if you have, say, measuring the volume of a piece of wood, or maybe even pumice, because pumice, the rock floats, you have to make sure it's underneath. And if that's the case, just take your pencil and gently poke it under. You don't want to put your pencil all the way under with the rock, but just enough so that you can get an accurate measurement. Record this measurement. Then take the water in the object, in other words, the final measurement, subtract the beginning water volume, and that's the object's volume. Now, this will be in milliliters. However, whenever you record the volume of a solid, it's got to be in centimeters cubed. So even if you took a rock and you saw this rock right here, if this was a rock and we put this in here and it raised 2 milliliters, we would still say, because it's a solid, it's 2 cubic centimeters. And that's the neat thing about the metric system. 1 milliliter equals 1 cubic centimeter. So as long as it goes up 2 milliliters, it's easy to say, oh, it's 2 cubic centimeters. The conversions are really, really simple in the metric system, not so much in the English system. The last thing we want to talk about today is density. Density is something we talked about in our last unit as well, or we're going to be talking about in our next unit on chemistry. So we're actually going to talk about it in 3 or 4 different units this semester. Now, the relationship between mass and volume is density. In other words, it's a mathematical formula. Density equals mass, and this little slash in here means it's going to be divided by, it's m over v, so it's mass divided by volume. And the SI units are grams per cubic centimeters for a solid, and usually it's cubic centimeters. It will be in here, but it could be cubic meters or cubic millimeters if it's a really small object. And if it's a liquid, it's going to be grams per milliliters. That's what it will be in here. We're not going to measure in liters, but it could be grams per liter, grams per centiliter. Now, suppose a substance has a mass of 10 grams and a volume of 10 milliliters. What's the density of the substance? Well, it's mass over volume. And mass divided by volume is 10 divided by 10, which is 1. Now, you might ask, density, what are we going to use it for? We're actually going to use it to identify objects. Okay? And, I forgot about temperature. We also need to talk about temperature a little bit. The measure of the average kinetic energy of the molecules in an object or substance is considered temperature. In other words, it's how fast those molecules are moving. If something is really, really, really cold, think of a solid. If something's really, really cold, it's not going to move very fast. Or if you've been outside in the winter time for a long period of time, your muscles are stiff, you're cold, you're not going to move very fast. Same thing with ice. It's so cold, those molecules are not moving very fast at all. But as you heat stuff up, those molecules start moving faster and faster and faster. So temperature is simply a measure of the average kinetic energy of the molecules in an object or substance. So keep in mind, you're actually going to need this definition for the temperature lab. Use this definition on the test as well. And typically, if you look over here, Celsius, that's what we're going to use in here. Now, the official SI base unit for the metric system is Kelvin, but a more common unit is Celsius. And the reason for that is Kelvin actually starts at a negative 273 degrees Celsius. And the reason why Celsius is so much better and so much easier to use is because 0 degrees Celsius, water freezes. 100 degrees Celsius, water will boil. So it's just easier to use Celsius versus Kelvin. And 1 degree Celsius, I would write that as 1, and then you'd have your degree symbol, and you see that right here, 1 degree Celsius. And we use a thermometer to measure temperature. So you're actually going to do a lab where you're going to work with thermometers, a glass thermometer similar to the one you see here, Always be careful though, because some of our thermometers have Celsius and Fahrenheit both listed on the scale. And just remember, 100 degrees Celsius equals the boiling point, which is a lot higher in Fahrenheit. So if we got a temperature and it's 153 degrees Fahrenheit, you know you made a mistake. You're measuring in Fahrenheit, not Celsius. So hopefully you don't make that mistake. So again, here we look at water boils at 212 degrees Fahrenheit and Celsius 100. If we were to go to Kelvin, the official one, it was actually 273 degrees. Where if you go down 0 degrees Kelvin is actually negative 273 degrees Celsius. So again, we use Celsius because it's so much more convenient. Water freezes at 0. It boils at 100. That's so much easier to remember than water freezes at 32, boils at 212. And it's much easier than using Kelvin as well. Oh, we got one more here. We got time. We're actually going to use time in several different units. And the SI base unit of measurement for time is the same as ours. It's the second. And 1 second, if I was to write it, I would just write 1s. And we're going to use a stopwatch to measure time in science class. I know some of you who read the measurement reading packets will know that there's a chronometer as well. You could use that, and that's acceptable, but we're actually just going to use a stopwatch here in class. And this does conclude the measurement notes. Again, if you have any questions or concerns, just talk to your science teacher. Thank you.